Welcome everyone. In this video lecture, we will solve a GATE 2018 question which is basically based on the diode small signal model. Okay, so in the diode small signal model, we have to find the AC current, that is our AC diode AC current in microamperage. So first we have to think about the problem. What are the known facts given in the problem? So it is already clearly mentioned that a DC current of 26 microampere flows through a circuit. Okay, a DC current of 26 microampere is flowing through the circuit. Okay, so it is given IDC. So IDC is given. So I am writing the given thing. Each IDC current equals to 26 microampere in the problem. Okay, after that flows through a circuit, and the diode is operating in the forward bias region. Okay, forward bias region, clear. And the ideality factor is given, that is our eta value. We know ideality factor, so the other known term is our beta value is 1. Okay, next, at the quiescent point, or we can say that at the q point, okay, or we can say that at the operating point, the junction capacitance is given 0.5 nanofarad. That is our junction capacitance. Okay, we are talking about the AC signal analysis. So junction capacitance is given. So we can write this one as a Cj equals to 0.5 nanofarad. In any question, we have to find the given item. So I am writing, and it is clearly mentioned we have to neglect the neutral resistance. So no need to think more about this term. And after that, at the room temperature, that is room temperature, the thermal voltage is given 26 millivolt. So Vt is given. Okay, so the other parameter is given Vt 26 millivolt. So these are the main parameters which are given. So we have to find the diode AC current. Okay, diode current in micro ampere range. Okay, so we have to find the diode current. Okay, we have to find this diode current in microampere, which is the small signal. So we have to find the, we can say, IDC. Okay, we have to find the value of IDC. Okay, IDC we have to find. So first we have to think about the small signal, a small signal diode current. Okay, so we are interested in the AC analysis. So what we have to make, we have to restructure this model by just converting this diode as a some resistive term, some AC small signal resistance of the diode, and the corresponding junction capacitance across the diode. Okay, so this one is nothing but simply we have replaced a diode with some small signal resistance. This RD is the, we can say, the small signal AC resistance, and Cj be the junction capacitance. Is it okay? Now, next. Now what we can do, we have to think about the AC analysis. So we have to find the value of RD, because Cj value is given. Cj value is given in our question. So we have to find RD. Okay. So first we have to find the value of RD. So how we can find the value of ID? So as we know, the diode current, that is our ID, is nearly equal to IS exp Vd by eta Vt minus 1. So I am just taking this one. So if we differentiate this diode current with respect to del Vd, it will give Is exp Vd by et eta, that is identity factor, into 1, Vd is 1, so 1 by eta V2, simple differentiation. And this term is nothing but simply id by eta Vt. What I am doing now, this one, okay, I am highlighting this one is nothing but simply our what, simply our diode current id by eta Vt. Okay, so it is clearly mentioned in our question the identity factor is 1, so it should be id by Vt. Okay, so the rd value is nothing but simply this del id by del Vd is nothing but simply 1 by rd equals to id by Vt. I think most of you know what is the value. So rd become Vt by id. So this one is the value of the small signal resistance across the diode. So the rd value is, Vt value is given 26 millivolt, and corresponding id is also given. The DC current in the circuit is 26 microampere. So this 26 cancel out, and here 10 to power minus 3 by 10 to power minus 6. Okay, and this unit should be ohm. So if we solve, it will give 10 to power 3 ohm, or in general we can write 1 kilo ohm. So we can write rd value is known to us, that is our 1 kilo ohm. Okay, so now rd value is now known to us. For any small signal analysis of diode, we have to know the rd value if you are looking for the small signal resistance value. Now we have to go for the AC current calculation. So for the AC current calculation, the diode is now replaced with the some RD resistance, that is our 1 kilo ohm resistance, and some this capacitance, that is our junction capacity. Cj is given, Cj value is given 0.5 nanofarad. Okay, 0.5 nanofarad. Okay, and one more resistance is there, that is our 100 ohm. So I am writing at 100 ohm, and after that we are just, this one is connected here, we are giving some AC voltage source. Okay, we have to make this grounded, and this one is nothing but simply 5 sine omega t in millivolt. Okay, it is in millivolt, I am writing here. Okay, so this one is now the new picture. Okay, so now we have to find the value of id, a small id. In my earlier video I already told the notation. If the symbol is capital and the subscript is also capital letter, so it is represented DC type. And if I is small and D symbol is small and subscript is also small, it is called as the AC current. AC notation, DC notation, and the instantaneous I already discussed. So now for the time being, what I am saying, if we consider this one, this whole R and Cj as some impedance, say Z, and this one is one resistance is there. So ID is equals to VAC, VAC we can tell this one as a VAC by what? Z plus 100. Okay, so if we find this ID equals to VAC by Z plus 100 is our nothing but simply our AC, a small signal current. Okay, so now I want to show how to solve this RD 1 kilo ohm and CJ. Okay, so now what I am taking this one as a RD. So RD say 1 kilo ohm, and now this capacitor is in parallel. So C, so the corresponding impedance should be 1 by SCJ. Okay, this part is clear. So the corresponding impedance, we can say the Z value is nothing but simply RD in parallel with 1 by SCJ. Very simple thing. Okay, we have to find the value of Z. So RD value is already known to us, that is our 10 to power 3 kilo ohm. So we can write as 10 to power 3. Okay, then 1 by S is nothing but simply J omega. Omega value is also given, okay, in question. And Cj value is already mentioned. Okay, so for the timing, again I am writing. So we can solve like that, 1 by j omega. Okay, we have to check what is the value of omega. Okay, I have not mentioned, but it is given here. I want to highlight this one. Omega value 2 into 10 to power 6. Okay, so omega value is 2 into 10 to power 6 radian per second. So I am writing this one, and Cj value is already given. Cj value, we can see Cj value something 0.5 nanofarad. Okay, so we have to write 0.5 into 10 to power minus 9. Now if we solve this one, it should be 10 to power 3 in parallel with 1 by j. Okay, 2 into 0.5 1, so no need to write. And 10 to power 6 into 10 to power minus 9 is that much simply 10 to power minus 3. Is it okay? Okay, so after that, again it is very simple. I am going very slow, but we have to go for the step by step process. So it should be 10 to power 3 j. Okay, so now we have this one. Now we have to solve this one, R1 in parallel with R2. So what we can write, it should be 10 to power 3 into 10 to power 3 by j divided by 10 to power 3 plus 10 to power 3 by j. Okay, what I am doing, if R1 parallel with R2, so it should be R1 into R2 divided by R1 plus R2. The same thing we are doing here. Okay, so it should be 10 to power 6 jj cancel out, and if we take 10 to power 3 as a common, it should be 1 plus j. Okay, very simple calculation. So the final result will be 10 to power 3 by 1 plus j. Is it okay? Clear? Now next. Now we have to find the impedance. Okay, so the impedance magnitude, so we are taking the modulus. So the modulus for this one is 10 to power 3 by 1 plus j. So it should be 10 to power 3. Okay, and the denominator part will be 1 square plus 1 square. Simple mathematics. Okay, then it should be 10 to power 3 by root 2. Okay, so the z value we have already find, 10 to power 3 by root 2. Okay, so id is, so I am writing here, I am taking some different color. I d equals to VAC by Z plus 100 from this circuit. We have considered these two impedances as Z. So Z plus 100. This one is the means process how to solve such question. So VAC is already known to us, that is our 5 sine omega t. So we are taking the magnitude. So we are just take the maximum value. So 5 sine omega t maximum value will be 1. So 5 into 10 to power minus 3. Okay. And z value. So z value. So okay, z plus 100. So now this one is z magnitude 1 z. So we have to add as a z plus 100 in the denominator, in that case. So better to solve this one in a separate place, divided by 100. Is it okay? So z plus 100 is taking 10 to the power 3 plus 100 root 2 by root 2. Okay. So it take common 100 common. So it should be 10 plus root 2 by root 2. Okay. So it should be 110 plus 1.414 divided by 1.414. Okay, I am just doing the mathematics step by step. So it should be 100 into now 10 plus 1.414. Okay, so we just add, it should be 11.414 by 1.414. Okay, then multiply with 100. So it will be 41.4, okay, by 1.414. So if we solve this one, it will come nearly 807.21. Use the calculator. So it will come 807.21. Okay. So in this case, now we have to just put the value of this one, 5 into 10 to the power minus 3 by z plus 100. We have already solved here. So it should be 807.21. Okay. So 5 by 807.21, and we have to write in the microampere. So if we solve this one by using the calculator, 5 by this one, so it will come nearly 6.2 microampere. Simple calculation is there. So the DC small current will be 6.2 microampere. This value may vary from 6.2 to 6.6 depending upon the calculation. So this one is the final result for the AC diode current equation. So in this question we have to think about the AC small signal resistance and this capacitance, and take this was a single impedance and try to solve separately z value and add z plus 100 because they are in the series one. So in this way we can find the final solution for the DC current, sorry, AC current. So it is around 6 point, so I'm writing here, it should be 6.2 microampere. So this is all about this question. So the question looks complex, but if we go step by step, it is just a simple question, but you have to go step by step and very careful calculation you have to do. So thank you for watching.